Okay, back for more here. This should only take about 5 minutes, so I really just have 2 examples for us to look at and a little bit of practice. What you need to be able to do also is recognizing the composition of functions. Oops, a couple little symbols here. And what we're going to do now in these problems is you're going to have the composition. The composition will be given to you, and you have to try and come up with the 2 functions that gave us that. So let's look at this problem, and sometimes there's more than one way to do these problems as well, okay? So if you can just take a look and see what might be the input for this problem, okay? We might have a function g of x equaling, you know, maybe what is under that radical, and then an f function equaling kind of the outermost function there, okay, which is the 4th root of something, okay? Now, so let's think about this. If we do f of g of x, just verify this, that means to take that g function, the blue function, and fill it into the red function. So the red function says to take whatever you're inputting and put it under the root 4, x plus 9. Okay, so you're just thinking backwards a little bit with these. Sometimes these problems give some kids some trouble. So they're at the very end of your assignment of the homework, so you can practice those. Okay. All right, 2 little practice problems here. One like the one I just showed you. So why don't you guys try this one? F of g of h. Find f of g of h. If f of x is x plus 1 over x minus 1, g of x is 2x plus 1, and h of x is x squared. Sometimes you can have multiple compositions here. So let's start with substituting the h function into the g function. So let's do g of h. Okay. So I'm going to take my h function, which is x squared, and plug it into the g function. So I'm going to take my x squared and substitute it in for x. Okay. Now you want to take that function and plug it into the f function. So we're going to do f of what we just got up there, which was, let's make that 2x squared plus 1. Okay? So that tells us to substitute in a 2x squared plus 1 in for x. And then we have plus 1 divided by a 2x squared plus 1, and then minus 1 in that denominator. Okay? And then simplifying there, we've got 2x squared plus 2. The 1's cancel in the denominator, so we've got just all over 2x squared, and that's going to leave us with x squared plus 1 over x squared. Do not cancel out those x squares, right? Okay, so that's just another little practice one to take a look at if you're having trouble. Okay, how about this one? This is a working backwards one. Express the function in the form f of g if the outermost function f of x equals root x plus 1. Okay, so once again, try to think about what you want to kind of input in here. So if I'm thinking that my g function is what I'm inputting, I can make that root x. And then my f function on the outside would just be x plus 1. So to verify that, let's do f of g of x. So take the blue function, root x, plug it into the green function, and we've got what we started with, the root x plus 1. Okay? All right, last thing is a little word problem. This thing here is a little word problem. I think this one came right out of your book. So this is just an example of when you can use compositions. Some of you might be able to answer this question immediately, part D, but I'm going to do it in parts for us, okay? So we've got a ship. It's traveling at a rate of 20 miles an hour, and that's parallel to the shore. The ship is 5 miles away from the shore, and then it goes past the lighthouse at noon. So let's just give ourselves a little picture of this. Okay, we've got, do it down here. We've got our shoreline there, and we've got our ship here. Okay, so we've got the shore. We've got our lighthouse, say, over here, and the ship is right here at noon. Okay? And that distance is, what was the distance again? 5 miles. Okay? So it's 5 miles away from the lighthouse at that time, at that point in time. It says express the distance between the lighthouse and the ship as a function of the distance it's gone since noon. Okay? So the ship is going, let's say, in this direction, and if distance equals rate times time, it's going to be, say, 20 times t, or something like that, you know, for your time. Okay? So if we want to call this our f function, we can say that the function in terms of the distance that it has traveled is going to equal, now what would that be? Okay? We've got distance since noon. Let's see. Let's say it's traveled over here. What kind of figure do we have there? A right triangle. Okay? So if this is my f of d, I just basically want to do, let me go back up here for you. F of d is going to equal the square root of 5 squared. Okay? Plus d squared, whatever that distance it traveled, okay, or 25 plus square root of 25 plus d squared. Now, if I want to express the distance as a function of the time that it elapsed, okay, then I can take a different function here, let's call this the g function, and say we've got a g function in terms of time, okay, and that would be my 20 times t, the rate times time. Okay, so basically all you're doing here is you can see the substitution. You don't have to be as explicit with this, but your function f of g of t, okay, would represent the distance of the ship from the lighthouse as a function of time. Okay, so again, here all you would be doing is substituting in 20t in for the d squared. Okay, because this represented your distance. Okay, so when you get that, you would just go and have the square root of 25 plus this time 20t squared. Okay, now again, I'm sure most of you could have made that jump right away, but I'm just showing you how the composition works with these functions if we want to simplify that. Okay, so once again, that would represent the distance from the ship to the lighthouse. Ship to lighthouse. Okay, as a function of time. All right, you're going to have time tomorrow in class to work on these types of problems. If you're a little bit confused, I will certainly be able to help you. We'll walk around and work on these problems together, okay? Then we will wrap up the chapter with section 2.8, which is inverses. And we'll be tested on this material later on in the week. I forget, one section is Thursday and the other one is Friday, okay? But I'll give you a heads up on that. That would be for the following week after the Columbus Day weekend. All right, guys, I will see you tomorrow.